Hey everyone, welcome back to The Explainer. I am so thrilled you're here. Today, we're diving straight into the absolute core of web security by unpacking a crucial curriculum module, authentication and authorization. If you've ever wondered how the internet actually keeps your private data safe, how it knows it's really you logging in, or why you can't just click a button to delete someone else's account, you are in exactly the right place. We're going to make these complex, behind-the-scenes systems completely transparent and honestly, pretty fascinating. You know, the fundamental problem with web security is that the internet at its baseline has zero memory. It literally suffers from permanent amnesia. By default, every single time you click a link, open a new page, or submit a form, the web server completely forgets who you are. So that begs a massive question, right? How in the world does the web manage to keep our bank accounts private, our emails secure, and our shopping carts intact, despite this total amnesia? To demystify exactly how this works, we've got a clear flight path today. We'll start with auth versus auth, then look at proving identity with sessions and JWTs. We'll explore staying logged in via refresh tokens, outsourcing trust with OAuth, and finally, setting rules with authorization. To keep things crystal clear, we'll be treating web security just like a highly exclusive nightclub.
All right, let's jump into section 1, auth versus auth.
People use these two similar-sounding words interchangeably all the time, but they actually represent vastly different concepts. First up is authentication, or auth-n. This is purely the process of proving who you are. Going back to our nightclub metaphor, authentication is the digital bouncer standing right at the front door. The bouncer stops you, looks at your ID, and verifies that the name on the card matches your face. That's it. It doesn't mean you get free drinks, and it doesn't mean you get to stroll into the VIP lounge. This step is strictly about identity verification. Are you who you claim to be? Now contrast that immediately with our next term, authorization, or auth-z. Authorization is the process of determining what you are actually allowed to do once you're inside. The crucial point here is that getting past the bouncer at the front door does not mean you have access to everything inside the building. Authorization is the velvet VIP rope inside the club. It dictates which rooms you can enter, whether you can go up to the DJ booth, or if you're just restricted to the general dance floor. So remember, authentication is who are you, while authorization is what are you allowed to do. Moving right along to section 2, proving identity with sessions and JWTs. Okay, now that we know what the bouncer does, how exactly do you prove who you are to a server with amnesia? Well, there are two distinct philosophies. First is session authentication, which is a stateful approach. It's kind of like leaving your jacket at a coat check. You give them your jacket, and they hand you a little ticket with a number on it. The club is keeping a physical record, a memory, in their back room. When you want your jacket, you show the ticket, they look up their records and hand it back. The server remembers you. On the other side, we have JWT authentication, which stands for JSON Web Tokens. This one is entirely stateless. Think of a JWT as a secure, unforgeable, cryptographic VIP wristband. The server doesn't keep a giant ledger of every single wristband it ever handed out. Instead, every time you walk up to a bartender, they just look at your wrist to see if the wristband is valid. They just read the token. It's incredibly efficient because the server doesn't have to look anything up in a database. The proof is right there on your wrist. Which brings us to section 3, staying logged in with refresh tokens. So, relying entirely on a stateless wristband introduces a pretty massive challenge. What happens when your JWT wristband expires? Because honestly, a forever valid wristband is a massive security risk. If a malicious actor steals your wristband, maybe they hack your browser or intercept your network traffic, and that wristband never expires, they effectively become you forever. They have total indefinite access to your account. To prevent this, security protocols make JWTs expire very quickly, sometimes in just 15 minutes. But obviously, that creates a terrible user experience. Imagine having to type your password into a website every 15 minutes while you're right in the middle of working. And that brilliantly leads us to the solution, refresh tokens. A refresh token is exactly what it sounds like. It's a special, long-lived credential used quietly in the background to obtain a brand new access token without forcing you to log in all over again. So if your 15-minute wristband expires, the bouncer doesn't just throw you out into the street. Instead, your browser secretly slides the bouncer your heavily guarded refresh token, and the bouncer quietly slips you a brand new 15-minute wristband. It spares us all the sheer frustration of being booted back to a login screen mid-keystroke, all while keeping the security party going safely. Next up, Section 4, Outsourcing Trust with OAuth. This is the next evolution of authentication.
It's a topic that sounds incredibly complex, but I guarantee you use it every single day. So, what is OAuth? At its core, OAuth simply lets a trusted third party, like Google, Apple, or GitHub, vouch for your identity to a completely different application. Why does this matter? Well, think about logging into Spotify for the first time. Instead of creating a brand new username and a brand new password that you will inevitably forget, you just click login with Facebook or login with Google. You aren't giving Spotify your Google password. Instead, Spotify is essentially asking Google, hey, do you know this person? And Google is vouching for you, saying, yep, we verified them, they are good to go. This just brilliantly illustrates how we bypass the local club's bouncer entirely by bringing a globally recognized celebrity to vouch for us. In step 1, the app, let's say Spotify, requests access. In step 2, the trusted provider, Google, takes over, authenticating you securely on their own servers, completely away from Spotify. And finally, in step 3, Google sends a secure token back to the app. Spotify never sees your password, they just receive the secure cryptographic proof that Google trusts you. It centralizes your security and radically simplifies using the web.
Finally, Section 5, Setting Rules with Authorization. Okay, so we're finally inside the club and verified. What happens now? Well, the most common way systems handle the VIP ropes inside is through role-based access control, or RBAC. In a classic hierarchy, down at the bottom, you have the viewer. They have read-only access. They can look at the data, but they absolutely cannot touch it. In the middle, the editor can modify access. They can write and change content. And at the very top is the admin, who has absolute all-access power over the entire system. Can you imagine the absolute chaos of giving every single user admin access? It would be like letting every guest in the nightclub run into the DJ booth, grab the microphone, and start pulling wires out of the soundboard. RBAC prevents that chaos by cleanly separating users into roles with very specific limits. And how are these roles actually enforced in the software? Through protected routes. Protected routes are the literal coded VIP ropes in the application. They're application-level barriers that check your authorization rules before the page even loads. If a viewer tries to type the URL for the admin dashboard into their browser, the protected route intercepts that request. It checks their token, sees they are just a viewer, and actively blocks them, usually redirecting them back to a safe page with a big access denied message. It ensures you only ever see the pages meant explicitly for your assigned role. We've covered a ton today: how we prove who we are with JWTs and sessions, how we refresh that access, and how we restrict actions using roles and protected routes. But as we wrap up today's explainer, I want to leave you with a final thought to ponder. With systems like OAuth centralizing our identities across the web, where just one Google or Apple account logs you into dozens, maybe hundreds of distinct applications, who truly holds the keys to your digital life? It makes our lives incredibly convenient, for sure, but it also concentrates a massive amount of power into the hands of those trusted providers. It's a fascinating balance between ironclad security, user convenience, and data privacy. Thank you so much for exploring this with me today. Keep asking great questions, keep analyzing the systems you use every single day, and I'll see you in the next explainer.